Hello everybody, and you're very welcome back to the channel. So yes, today we are in a little bit of a different setting. We're out in the man cave. We have some tools. We have a great big starter motor here. So today, yes, is all about the starter motor. How it works, how to diagnose it, things to look out for, how to strip it down and how to repair it. Things that most commonly go wrong with starter motors if you have an issue with one, and what you can do to save yourself a few quid. Because sending it in someplace to an auto electrical shop, or to get somebody like me out to take it off your tractor or take it off your machine to strip it down, rebuild it, you're into hundreds of euros. So there is things that you can do yourself and things you can check. Because a lot of the time I do find that when I go out to something that somebody says, there's a problem with my starter motor, come out, it's generally not the starter motor. It's either the battery or the battery leads or an ignition switch or something like that. That is the issue. And you can, if you just have a little bit of knowledge about it, you can very easily diagnose these starter motors yourself. Now, if you want to know more about batteries, if you want to know more about relays, because relays do feed the starter motor, I do have more videos on the battery, how to test the battery, how to test the leads, and a whole video on the relay itself and how to test relays and how they actually work. But today is all about the starter motor. So yeah, we're going to get straight into that now. But first of all, to all my new subscribers, everyone that watched the video on the John Deere 50 series from last week, thank you so much. I literally had messages from all around the globe, from Australia, from Canada, from America, from Northern Europe, from Poland, from England, and of course from Meath as well, and from Ireland. Thank you to everybody who got in touch, whether it was by email, whether it was messaging on Facebook, or whether it was messaging on YouTube itself, or some people rang me up. I had phone calls from a few different guys looking to have a chat, some people looking to get some work done on the tractors that I could maybe help out with, and yeah, I'd be delighted to do that. So yeah, that was great. Thank you so much to everybody. But today is all about the starter motor, and we're going to get stuck into it straight away. So here we have it. This is our standard 12 volt starter motor. This particular one is a 2.2 kilowatt, so I suppose in old money, what's that, 3 horsepower ish, and this is out of a diesel Mitsubishi S4S engine out of a 3-ton forklift. So yeah, the issue with this one was, now I haven't stripped it yet, so I don't know what I'm going to find inside, but I have a good idea going by what the customer was saying as to what the issue is. So they were complaining that this starter was lazy, and you'll hear different terms, people saying, oh, it's lazy, oh, there's just a clicking noise coming out of it, or there's smoke coming out of it, or it's slow to turn over. And as technicians, when we go out to look at starter motors especially, the description that the customer gives is vital as to what's happening and what the history is as to what we might check first. So the first thing to check, obviously, when you go out to check a starter motor or to check a non-start issue where a customer suspects it may be a starter motor, is the battery. So we start with the battery. We've done a video, as I said, on the battery before. So I know that the battery in this machine is perfectly fine. I've checked it. It's 100% fine. I know my earth leads are fine because I have checked them. I've done a resistance check on the earth leads and on the positive lead and on the fuse. Everything checks out. Everything is fine. So we're down to looking at the starter motor itself then. So we look at this, we come to the starter motor. The first thing we're going to look at is the connections on the back of the starter motor and on the solenoid. So for those that don't know, this part here, this is the solenoid. And what a solenoid is nothing more than a switch. So a solenoid is an electrical switch. So we have the solenoid, we have the back plate on the motor, we have the motor body itself. On this particular one, we have a gearbox, and then we have our Bendix with our little clutch inside in it. So what I'm going to check, the first thing I want to check is that I have 12 volts coming to this point here. So this point here is our main battery feed lead coming directly from the battery through our pre-fuse. So that would be and it could be, depending on the machine, an 80, 100, 120 amp fuse. That's going to be a large fuse feeding that large connection. So that's normally held on like with a 13 mil nut for a 13 mil spanner. So our second connection then is going to be this one here. Now this is a bolt-on connection, has a small screw that holds it on. So most of them are just spade connectors that clip on, but most tractors and heavy duty stuff would have a little screw or a bolt that would screw into it to hold it on. So this one here, we're going to have power at all the time, pretty much all the time, unless, you know, it has a battery switch or something on it. So we want to check with power there. Okay, so I know I have good power there. So the next thing I want to check is to make sure I have power coming to this switch. So what this switch is, where does the power for that one come from? So I'm just going to revert to a little wiring diagram that I have set up here. So if we look here at our wiring diagram. Okay, so here's our battery. Battery's going to earth. Okay, so now we have this heavy wire. This is the heavy wire we spoke about. Through 100 amp fuse, coming down into the solenoid on our starter, like we described. That's the one that's held on with like the 13mm nut. So then we have the small feed, so the small current feed that's going to come from our ignition switch. So this is through our ignition switch down into our relay. The relay will switch and then it will send ignition power down to the solenoid to start our vehicle. So when we look at the function of the starter motor, so what is the function of the starter motor? Its purpose obviously is to engage with the ring gear and start our, you know, internal combustion engine or piston engine, get it up to speed, get it starting. But the function of a starter motor is to convert what we have here, electrical energy, into mechanical energy, and the mechanical energy will be coming out at our bendix, at our little gear at the end of the starter motor. So the function of a starter motor is to convert electrical energy to mechanical energy. The same way our battery's function is to convert chemical energy to electrical energy. Okay, so here we have our starter. So we know we have power here. We're checking here now with our multimeter. So the best thing we can do here is we can just set up our multimeter. We have our starter motor. Now I used for diagnosing starter motors, I'm generally on my own, so I like to use these clips. So I'm going to put that connection onto my ignition feed from my starter motor. This one here obviously is going to go to earth. Now a good earth is generally onto the starter motor itself or back to the battery. Knowing that all our connections, all our earths are good, I can safely put it on the starter motor and be happy. Something's onto the body of the starter motor. And then I'm going to crank. I'm going to turn the key, either get someone to do it or do it myself if I can have the meter in a position where I can see it. On forklifts and that, it's quite easy. So you switch it on. Obviously I'm not connected up to power here, but you get the idea. That should be coming. So we should be getting 12 volts from our ignition switch. When we switch the ignition on, you will hear maybe a click, you might hear a spin, you might hear a crank. It depends on what the issue is, but we want power there. Now you often hear people saying, oh, just cross the starter motor to get it to start. Now, while that is an old trick that you can do to bypass everything, so you have your lead here, your 12 volt lead from the battery, maybe you have no power coming here from your ignition switch. So what people will do is they will just bridge them there like that. That's called crossing the starter motor. Now that will start. It will turn if the starter is good, it will turn the starter. But obviously what you're doing there is you're bypassing every single one of your safety devices that are built into the machine itself. That could be a seat switch, it could be a hydraulics lockout, it could be a neutral gear switch like you would have on your Massey Fergusons. And all machines will not start unless they're in gear. But if you cross the starter motor, you're bypassing all that out and you are at serious risk to yourself and to others. So unless you are 100% certain that it's out of gear and everything is okay, you do not cross the starter motor. Now, as a professional, I have to say that, but it is a way that people use to bypass the ignition switch. The other issue you can have is maybe the hydraulics on the machine dropped overnight. You come in the morning, you go to start it, and the hydraulics start to lift up as you're crossing the starter motor because the pump starts to run. So I would highly advise against crossing the starter motor. Have the machine fixed properly. So yeah, that's it. So that's basically our two connections: 12 volt from the battery, 12 volt from the ignition switch, and our other connection is the motor itself. So that is your earth. So your earth for the system is going to come through the body of the starter. Some will have an earth lead coming maybe from the back of the starter motor. onto the body or back up to the battery, just to make sure you have a good connection. So that's it. So what we're going to do next is we're going to get the tools out, and we're going to strip this baby down and see if we can see anything wrong with it. Remember, I said that the issue with this is a lazy start. Okay, so what that means is the customer goes to start it and it kind of goes, it might skip for a little bit, it'll go rrr, rrr. It'll be like a slow kind of fast, slow sort of turnover, and it will eventually fire. So yeah, we're going to get into it now, and we're going to strip it down. So the first thing we're going to do is we're going to have all our tools ready. You do need very, very little tools to strip a starter motor. So the first thing I'm going to do is going to take off this power lead that comes down into the motor, and we'll explain how it gets its power in a little while. So I'm going to take off that 13mm, right? So that comes off. Try and leave all our bits and pieces, all our tools, nuts and bolts in a safe position. The second thing I want to do next is, so what I like to do when I'm stripping them down, especially a starter motor that I haven't stripped before, that I'm not familiar with the type of starter motor, I like to index everything. So everything goes in it runs in a line. So you know, you can't put plates on in different positions, solenoids on in different positions. So I like to index everything with a permanent marker or something like that. So I might come to the top here with my solenoid, and I will just put a little mark on it, permanent marker. It'll just mark it, so I know what way it goes back on. Sometimes it's very obvious what way to go, but just to be on the safe side, just index everything that you know where they're going. Yeah, so next thing we want to do is take off our back plate. So the two screws that clamp the whole motor together and hold on our brush pack at the back. I'll just get my trusty Milwaukee. I don't know where I'd be with it, my little Milwaukee guns. They just make everything so much easier and so much quicker. Everything nice and tidy and neat. So we just want to be a little bit careful pulling off the back plate, because it does contain the brush pack. Okay, so when we pull that off, everything is going to come. Now we're into the bones of it. Okay, so our brush pack, then there's two screws on the back of it, and what we will do is we'll take those two screws out. That retains the brush pack into the back of the housing. So already I can see an issue. Maybe you can too if you know what you're looking at, and it's exactly what I expected. So we'll just talk through the parts first, what we have here on the bench in front of us. So everything is made up of different parts, and how the current flows around the starter motor and how the starter motor actually works. So what we have here is our solenoid. Power comes in, as we said, power comes into the solenoid. From our ignition switch, we have the power from the battery. So when our solenoid pulls in, what it does is it does two functions, and I'll show you by taking these off. That wasn't supposed to happen. So there's our solenoid. That's just a little shim, just a little spacer. So that's our solenoid. Okay. As I said, solenoid is an electrical switch. So power comes in from the battery, from the ignition switch. We have two coils inside in the solenoid. One is called a pull-in coil, one is called a hold-in coil. So what the pull-in coil will do is it will pull in this rod in that way. And what that will do is it will trigger another coil. That's called the hold-in coil. So we need to hold that in. So the pull-in coil will pull that in through electromagnetic force, and the holding coil will hold it in until we release our hand off the ignition switch. So I have a little diagram here just to show what is actually going on inside in the solenoid. So we take a look at our solenoid. So that's basically what we have there. That's our solenoid, okay? So we have our 12 volt feed down from our battery, heavy feed into the top of the solenoid, which is this one here, represents that one. And then we have the other wire that comes out, goes down into our the body of our starter motor. Okay, we've got one coil here and we've got a second coil here. When we get the power from our ignition switch, from the ignition relay, down into the coil, that coil through electromagnetic force, we know magnets repel each other, so if we set up a magnetic field here, and inside in that we have an iron rod, that's going to cause, if it's set up properly, it will cause it to move. So we've got two contactors here. So turn on our ignition, pull in coil, pulls in this rod and bridges these two contacts. So now we have 12 volt supply come from our battery through the contacts, down, out and into the starter motor, and that's what will send the power down into the motor itself. The holding coil then will hold it in position until we release our ignition switch. Now, do the solenoids give trouble? Yes, they do. The solenoids give a lot of trouble. So what happens to them? Generally, the windings might break down. There might be a breakdown in the windings in one of the coils. It might pull in, but it mightn't hold. If it doesn't pull in, it'll never hold. So generally, you might hear a click. It might pull in, but it won't hold. It might pull in. It won't bridge the gaps because these contacts are burnt out. Is there anything we can do with a solenoid? No. You just throw it away, get one off a shelf, stick it onto it. The rod coming out the other end then, that has a separate function. So as I said, the solenoid has two functions. One function to bridge the contacts down into the starter to send power to the starter motor. The other function, which is represented here in that lever, what that does is it will catch onto a little hook there, and that will engage our bendix here, our drive, with our flywheel. So that's what catches onto the flywheel of the engine to turn it. So a solenoid has two functions. One is to bridge the contacts and the other is to pull in the bendix and engage it into gear. Now we'll leave that aside for a minute. So the next part we're going to look at is where the power comes in. So what we have here now is our field windings, it's called. So they are that we'll have a magnetic field built up in here when there's power sent down to it through the windings. What you will have here is north, south magnetic field. So you will have a good, strong magnetic field within these field windings inside in the coil. Okay, so that's straightforward. The power comes from our solenoid straight down into our field windings, and we have a magnetic field set up inside our field windings, around the field windings. The other part then comes from this baby here. So what this is an armature. So again, you've got windings in here, and you've got all these little lines with gouges taken out of them. Now those gouges are out of them when that was balanced when it was being manufactured. They balanced those, so they just take little bits of weight out of them to balance them out, get the balance right. On the back of the armature then you have a bearing. Now some have like a bronze bearing, some have roller bearings. Heavy duty ones more so will have a roller bearing, tend to have a roller bearing. Some will just have a bronze bearing, and they give trouble on them. The bronze bearings will wear out, the ball bearings will wear out, the roller bearings will wear out. But what you will find on these is if you take one apart, what you can often find is this is the armature, this is the commutator. So this is where our brush pack runs. So in here we have brushes. So I can tell that those brushes, they're all pretty good. They're not worn. They've got good strong spring contact. You might get one, if you strip one down, that the brush pack is stuck like that. It might be stuck out, it might be completely worn down, and it's not making good contact with the commutator. So that's vital that it makes good contact, because it sends power from the commutator down into these windings in here. So you have a path of electrical current coming down into these windings. And that's very, very important. So the first place we can have trouble is the brushes. Brushes wear down, they stick out, you're not getting contact, and what will happen is you'll turn the ignition, you'll hear a click, and nothing will happen. You won't get a spin, so because you won't have current flowing properly down into the commutator, through the commutator into the armature. So what can we do with that? Well, if that's not too badly worn, what people do is, if you have a small lathe, you can set that up in a lathe and you can actually skim them. You can take the groove out of it, you can clean them down, or you can rub it with a piece of emery and get it nice and smooth, and clean out all these little gaps in here. Very important that they're cleaned out. Scrape them out, clean them out, and give that a slight rub of emery. If the brushes are worn, the only thing you can do is to replace the brush pack. Now you can generally get brush packs for most yokes. So you just break the solder. They come as a pack, break the solder, and they do have to be resoldered. If you're good at soldering, that's fine. If you're not, get someone else to do it. It's only 2 connections. It's a 10-minute job to somebody who knows what they're at. But that is probably the main cause of starter motor failure, is the brushes. And then dirt and grit and grime and crap building up on your commutator. So that's quite important. So what the brushes do is, the current will come in, it'll come down here from the starter motor, and it'll flow through the brushes at your 4 contacts to supply your armature with power. Then we have north-south on our field windings, and we have a magnetic field set up on our armature. Now everybody knows, and I have a couple of magnets here. When you played with magnets as a kid, or maybe you still play with them as an adult, they will repel each other and they will attract each other. So if we can set up a magnetic field, set up magnets up in a specific way, they will keep trying to attract and repel each other. Therefore, what will happen is, when they're set up in that magnetic field, that motor, it'll just want to keep turn and turn and turn and turn and keep turning and keep turning and keep turning. And that's what creates power. Now the power of the starter motor obviously will depend on 2 things. Number 1, the size and strength of your field windings, and obviously the power comes from your battery, the current comes from your battery, your 12 volt, your 24 volt, because volts is pressure, and the more pressure you can get down into it, the better. This is obviously a 12 volt starter motor. So so the brushes are the first thing to look at. Brushes, commutators clean, not grooved, not worn, no dirt, no crap on it. And then connections. Field windings rarely give trouble. Commutators rarely give trouble. Unless on a big old machine and it got a lot of heat into it, and they started to melt or something, that does happen. But that's generally not the fault of the starter motor. That is generally down to the fault of either a bad battery or bad leads, bad connections, something like that, that can cause issues. Because just to get a little bit sciencey on it, if we have a 12 volt system and our starter motor, if we're running at, say you're cranking at 1000 amps or 300 amps or whatever it is, with Ohm's law, our resistance within our circuit is going to be fixed. But if our voltage drops, or our resistance drops, if something drops, the current the starter motor is going to increase. So that's what will create the heat. The starter motor might not have been designed to take maybe 1000 amps or 1200 amps or 1600 amps. It depends on the size of the starter motor. If anything in the system is off, if there's too much resistance, too little voltage, something will be off and will create heat inside in the system. But you will generally see a lot of melting, a lot of burning, a lot of scarring and stuff on the commutator and the armature. That's it. So the brushes, armature, commutator and armature obviously give trouble. The next place we're going to look for, and this is where I was expecting to see issues with my one, was in the bearing. So this bearing at the end, while the bearing feels, I don't feel any play in that bearing. If I put it into the housing here, I can see in the housing, see all that dust, all that dirt, all that crap. That's all bits of metal. So what happened is the housing is worn away here. The housing, now when I say worn away, it might only be a couple of thou. It might only be a very, very small amount. And there is play in that. I can feel a little bit of play in that. So that's where my issue lies with this starter motor. At least this is one problem. And that was what I was expecting to see, because when you have a lazy starter motor, what's happening is our armature is inside in our field windings, and the gap around it has to be centered perfectly for it to work properly. But if it's off a couple of mil or a couple of thousandths of an inch, it will create that lazy effect where it'll try to start and then it'll stop and it'll try to start. It's not centered properly within the field windings. And if you have a machine that has a lazy starter, you can be nearly guaranteed that it's either a bearing or it's wear in the back housing, or if it has a bush, the bush is going to be wore out. The only option for this starter motor is to change this casing, and they can be got properly because there is no bush in there. It's actually just worn through it. So they generally, if they're working in dirty conditions, they will get dirt and crap into them. So that housing needs to be replaced. And the bearing, you could replace the bearing as well. You're talking about a few euro for a bearing like that. Very, very simple. Very, very simple to replace. So that's it. So that's that end of it. So when we look here at the other end of it, where the power goes when this all starts to turn, what happens? Where does it go? Well, obviously, and not all starter motors, but this is the way this was presented. So what happens is, take the cap off. Obviously, you've got dirt. That's a dust cap. It's to stop dust and dirt getting into what we have in here. So this is a geared starter motor. So we have a planetary setup here. Planetary gears. Why do we need planetary gears? This is out of a quite semi-large diesel engine. So we need good torque. We need good torque to get this machine going. So what we have is the planetary gear system. Now, do they give trouble? Oh, they do from over cranking. It's very, very rare to be issues with them. Issues more arise when the bearing gets, when it collapses too much and they just get abused. So what you do is, what you can do is you can just have a look at it. Take that off. So they'll just come out. We'll just take them out. Can you replace them separately? Yeah, of course you can. Yeah, no problem. Get a set of planetary gears. I've never replaced one of these. Never. I've 30 years as a technician. I've never had to replace any of these. So you have another bush in here, and that's quite important. What you also have is a ball bearing. So that ball bearing initially was down there until it fell out when I was disassembling it. And what it does is it locates with the end of our armature shaft. So that armature shaft runs in there, locates onto the bearing, and that helps center it. And it is quite important. They can fall out quite easily, as you can see there. It's sticking to it. They can fall out quite easily, and if you don't have that bearing when you're reassembling it, what can happen is that the it will run offline, and you'll have premature wear, or it might not start at all. So that's it. So obviously there's our gear, our planetary gears run on that. That'll be our sun gear, if you like, planetary gears, and then our fixed ring gear around the body. So the next thing to check is that shaft into that bush, and when I put that in there, I'm expecting a little bit of play. And there's quite a little bit of play. There's more than a little bit of play. So yeah, that's not great. So there's my two issues: front bearing and back bearing. And that's what I was expecting, given the symptoms that the customer had given. So what we have here is, obviously, we remember from our solenoid. Our solenoid connects in here. So what our solenoid will do is it'll pull and engage. So when it pulls and engages, what it will actually do is it'll rotate that. It's on a spiral. I don't know if you can see it there now or not. I'm just not going to strip the gearbox. But there is a spiral shaft in there. The shaft that runs on a spiral. So when it engages, it spins that shaft slightly and engages with our ring gear. And when it engages, obviously the solenoid sends the power down. Power comes through our commutator, down into our commutator shaft, into our planetary system, and turns. So that will engage the bendix onto the ring gear and turn. Now what we do have in there, built into it, then you have a clutch mechanism built inside in there. So when the starter motor kicks in, turns the engine, and the engine starts to fire, instead of damaging our Bendix gear, it will overrun the clutch, and the system is safe. Let go of the ignition switch and it will pop back in. So that is basically it. That's how it works. That's how, there's our shaft that's connected directly to our Bendix. With the clutch mechanism inside, you can see I can turn that shaft one way and it will not turn the other way. But if I turn it this way, the clutch is engaging with the Bendix. So that's our safety system for when the engine eventually does start, to prevent overspinning, overrunning of our motor. Generally, there's very little that goes wrong inside. I've rarely seen any issues with the planetary system other than maybe worn teeth or worn gears. Get them separately, throw them into it. They're simple. You just need to check the play there, but very, very rarely they give trouble. Other than that, that's basically it. That's the main things: our brushes, commutator, burning on our armature, and then most importantly our bearings on the end of our shaft and in our cap, if there is a bush or a bearing in there. So we know with this one that the play is here and the play is in this side here. So with that, we're running offline inside in the field windings. We know that's what our issue was. So I am going to get a set of bearings for that. I'm going to get a bearing into that. I'm going to get a cap and stick a cap into it. Now, if you're a good engineer, if you have a lathe, if you if you have a milling machine, you can actually just mill them out a little bit and get a bush made for it, or maybe get a bearing that's a little bit bigger. But you would want to make sure that it is done properly, that the system is centered. So after that, that's it. So our solenoid is the first one to check, and then work the power down around. They are very, very easy to diagnose. There's very little that goes wrong with them. So yeah, I did mention that there are other ways that we as technicians can use starter motors to diagnose problems within the car, within the tractor, within whatever it is. So what you have to remember is, I'm taking it that I have a 4-stroke cycle. I have a 4-cylinder engine. So if you give my artwork here, but basically what I have is I've got a drawn out scope signal. So you have to remember that when the starter starts to turn, it doesn't just deliver a constant supply of amps down into the starter motor through the engine. It's not a constant supply of amps. It will peak. And why will it peak? Well, it'll peak because the demand on the starter motor changes with every cycle. So every time there's a compression stroke, the demand on the engine, on the starter motor, peaks. So when number 1 is coming up on compression, so we're starting from 0 here, our engine is stopped, it's idling, so we turn the ignition and we crank. So initially we're going to get a huge, because the engine is stationary, we're going to get a huge spike in amps, or say up to 1600 depending on the application. Huge spike, so that's cylinder number 1. So then we come down and we get another spike for the next cylinder, another spike for the next cylinder, another spike for the next cylinder. So the firing order of this engine, as most 4-cylinder engines are, is firing order 1, 3, 4, 2. So cylinder 1, spike, 3, 4, and then as the engine starts to turn, 2, 1, 3, 4, 2, 1, 3, 4. So you'll get this you'll get this spike along the graph. So here we have time, we've got seconds, so we're just cranking, and then maybe you stop the ignition or it starts and it drops off. So how do I get this signal? Well, I have to use what's called an oscilloscope or a scope. Just putting an amp clamp on to a lead, it won't give you the, with the times that are involved here, you're talking about milliseconds. You won't be able to read it with a standard meter. What you will need to do is put on a scope if you have access to a scope. If you are a mechanic, you can stick a scope on, and this is what you're looking for. You're looking for a nice clean pattern of demand from the starter motor. So everything's even when it's cranking. 400, say around 400 amps the whole way along. that's a good signal. That's what I'm looking for. Initially, you'll get a spike because the engine is not running until it settles down after a second, and then crank, 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 crank. That's good. Okay, so where can we use it to diagnose issues in the engine? So if I have a misfire in my engine, if I have something going on, that's going to change. So the demand on the starter motor is going to change. So what we carry out is called a relative compression test. Now, it's not giving me a PSI readings, although some modern vehicles, some of the modern Mercedes and that, you can do it through the ECUs and that. You plug in a diagnostic computer, you can do a relative compression test, and it will give you, through the logic that's built into the computer, it knows exactly what the compression is going to be based on the parameters of the engine and what the current draw is on the starter motor. But again, what we're looking at here is the same. So huge spike at the start because the engine is stationary, 1600 amps, and then it's going to drop into 4, into 2. Now we missed 3 here, so what's that telling us? We don't have a spike where we expect 3. So then we're down looking at our graph here. 2, 1, flat line, 4, 2, 1, flat line, 1, 3, flat line. So this is telling us that we have an issue on one of the cylinders. So we have no real spike of current draw here. We have a little draw. It might even be dropped off more than that, where you have nothing. If you see that, you have little or no compression on that cylinder. So that's telling me that I have a problem with cylinder 3. I've got low compression. Now, if you scope it and you haven't got the timing set up, it mightn't tell you exactly what cylinder it is, but it will tell you that there is a problem. So if you get that, flat line or a negative spike on your oscilloscope, it will tell you. We can use the starter motor to diagnose compression engine issues within the engine, and that's something that I would do quite regularly. It's a huge help. So yeah, that is it basically. That's how we can use it. If you are a technician, I don't expect normal people, average tractor drivers or operators or home mechanics to be able to do that, but it is a way that we can use the starter motor. So that's it, guys. I'm not going to put it back together because I do want to get a bearing for that, and I want to get a bush, and I will put it back together. I'll probably just stick it up on eBay or on Done Deal or something. Maybe somebody will take it off my hands. But yeah, thanks a million for watching. If you have any questions, if you felt that I left out anything, please don't be afraid to jump in and say. But that's the basics. They are a simple electromechanical device, and there's nothing crazy about them. You will get some maybe. If you go to, say, the solenoid, it might have 4 or 5 connections. That is because the relay is built into the solenoid. Some of the heavier plant equipment might have a relay built into the solenoid. But in general, when it comes to your tractors, when it comes to your cars or your dumpers or anything, that's as simple as it is. There's a few different designs of styles of housings and stuff, but they're all, the principles, the basics are all pretty much the same. So yeah, thanks for watching. If you have any questions, please don't be afraid to drop them into the comments. If you've replaced the starter motor, if you've rebuilt one, if you have taken one off, put a new one on, and it made absolutely no difference, please give us a shout. Drop a comment into the comment section, and I always reply to all. I love getting comments. I love interacting with people. I reply to every single one of my comments on the tube, and it's something that I'm very, very proud of. So yeah, that's it. So the next video in this series is going to be obviously on the alternator. So I will talk to everybody next week. We'll be back with a tractor video next week, and I'll talk to everybody then. Thanks for watching.